Okay, so let's try to graph a polar curve. So we have r of theta is 1 minus sine theta, which is, as we all recall, the heart butt.
The what?
The heart butt?
It looks like a heart.
It looks like a butt.
The question is second.
It looks like a heart or a butt, depending. Okay, anyway. So first thing you do is you know what 1 minus sine theta looks like in terms of r and theta, right? Like just as a regular function, you know how to graph 1 minus sine theta. So you make yourself a set of axes that are r and theta axes. And then what's 1 minus sine theta look like?
It's sine shifted up, one is flipped over.
Okay,
Or
it's
flipped
sine
over is then
flipped over and then shifted up one, right? So it's going to go between what? Sine normally ranges between 1 and negative 1.
1 at 2 and 0.
So this is going to go between 2 and 0, right? So here's my midline. That's at 1. My top, that's at 2. And the bottom is here at 0. And then it's sine, but flipped over, right? So it's going to look like this. Okay, where's this first trough? That's at pi over 2, and we didn't have any compression or anything, so it's still just at pi over 2. This spot where it crosses the midline again is pi. Top is 3 pi over 2, and it crosses the midline again at 2 pi. Cool?
you want to go to 2 pi because that's all the way around.
Yeah, and you want to go to 2 pi because that's once around the circle, right? You want to go to at least 2 pi. If you want to trace this out again, you could maybe run it again and just make sure you got the same thing. But you definitely want to go to at least 2 pi. So what should I split my x and y axis into? Yeah, I should split it into radii, right? So I'm making polar graph paper. So I'm going to make a circle of radius 1 and a circle of radius 2. Do I need to make a circle of radius 3? No, we don't need it because the r's are stuck between 0 and 2. Cool? All right, now where are my important angles going to be? Do I need more angles on here?
Yes, every 45.
345, you think? Okay. I think I can probably get away without them, but sure. Okay, so I threw my pi over 4s in here. Now, what's the first chunk of this that's happening?
Oh, down.
Yeah, so the radius is going from 1 to 0, right? As the angle goes from 0 to pi over 2. So we start out at a radius of 1. And then as my angle changes from 0 to pi over 2, so as I go through this first quadrant, my radius goes from 1 down to 0. So that's going to look something like this.
Why is it going up?
Because as my angle goes from 0 to pi over 2, the radius goes from 1 to 0. There was a little compass over here. Try that with this. So, big version, right? As I go from angle of 0 to angle of pi over 2, my radius is going to come in, right? So I'm going to kind of cheat this and draw it huge. So, as we go up, right?
Okay, I can't see that.
Like this is obviously not working well, but that's basically the idea. Okay. All right, what's the next section on here? From pi over 2 to pi, the radius is going from 0 to 1. So pi over 2 to pi is in this quadrant, right? And the radius is going from 0 to 1.
So it's gonna look the same thing.
So it's going to look like the same thing backwards. And then from pi to 3 pi over 2, that's in this quadrant. My radius is going from 1 to 2. So just something like this. And then in the quadrant between 3 pi over 2 and 2 pi,
It's 2 and 1.
we're going from 2 back to 1. So we get something like this. There's my cardioid again. Cool?
So why is it going to 2 on the y-axis?
So this dot right here,
Uh-huh.
right, corresponds to radius is 2,
Oh, okay.
angle is 3 pi over 2.
Okay.
That's
Sorry,
like go to an angle of 3 pi over 2 and then out 2.
That makes sense. Okay. I was thinking the wrong side.
Cool? Any other complaints?